Question number 1. Green sand mold indicates that options: polymeric mold has been cured, mold has been totally dried, mold is green in color, mold contains moisture. So there are two types of mold. One is dry sand mold and green sand mold. In the dry sand mold, that is, it contains moisture. The green sand mold contains moisture, whereas dry sand mold, it is baked and it doesn't contain any moisture. So option is D. Green sand mold contains moisture. Second question. In a green sand molding process, uniform ramming leads to less chance of porosity, uniform flow of molten metal into mold cavity, greater dimensional stability of the casting, less sand expansion type of casting defect. So option is greater dimensional stability of the casting. Uniform ramming leads to greater dimensional stability of the casting. Next question. The process generally preferred for manufacturing of wheels and pulleys is casting. Okay, the large wheels and large pulleys, flywheels, everything are made by using the process casting. So option is C. Disposable patterns are made of wood, rubber, metal, polystyrene. So disposable patterns are made up of polystyrene. So it is not used again. So they are made up of polystyrene. So option is D. Which metals can be used for making patterns? So aluminum can be used for making pattern. Wax, it is a last wax investment casting. Wax is used as a pattern. Lead can also be used as a pattern, but mercury cannot be used as a pattern. So 1, 2, 4 are correct. So option is C. 1, 2, 4 are correct. Mercury is not used for making patterns. Skeleton patterns are generally used for large castings. Patterns can be of different types: split pattern, follow board pattern, match plate pattern, that's C diagram, and loose piece pattern, sweep pattern, and skeleton pattern. So the skeleton pattern, so it can be used for making large castings. Okay, hollow castings are centrifugal castings, and non-ferrous metals hot chamber die castings. Small castings, okay, so the skeleton patterns are generally used for large castings. Arrange the following steps in correct sequence with respect to the step of casting process. Okay, so solidification, melting, ejection, cleaning, and pouring. So the option is C. First we have to melt. Okay, then we have to pour 5. Then the first one, solidification. Okay, melting, cleaning, solidification, ejecting, and cleaning. Okay, 2, 5, 1, 3, 4 are the steps of the casting process. The part of the gating system which regulates the rate of pouring of molten metal into the mold is, options are choke, riser, pouring basin, and runner. Okay, see the diagram. So this is a runner. Okay, it comprises some important parts. That is, this is a riser. Okay, and this is a mold cavity, and this is a choke, and this horizontal way is called as runner, and this is a sprue. Okay, through which the molten metal is poured into the mold cavity, and the sprue pays well. Okay, and this is a skim bob. So the choke, this is a choke, the part of the gating system which regulates the rate of pouring of molten metal into the mold is choke. Okay, the option A is correct. Okay, it regulates the rate of pouring of molten metal into the mold. Next question. Which one does not form a part of the gating system for a casting? Okay, pouring basin, sprue, choke, and pattern. So in casting, pattern is removed after the molding process. The pattern is removed. In the casting process, it consists of pouring basin, sprue, and choke. So pattern is not present in the gating system. Okay, so option D is correct. Light impurities in the molten metal are prevented from reaching the mold cavity by providing a strainer, button well, and skim bob. Okay, so light impurities that is, when it is poured into the mold cavity, it can be prevented by using this strainer, button well, and skim bob. All of the above. Answer D is correct. Then sand casting mold assembly is shown in the given figure. The elements marked A and B are respectively option A drag and riser, B ingate and riser, C sprue and riser, D riser and runner. So this is a mold cavity and this is a riser, B is a riser, okay, and A is a sprue, okay, A is a sprue and this horizontal path is called as a runner. So A is a sprue and B is a riser, okay. So riser is provided to there is during this solidification some metal the metal contracts. So in order to compensate for the metal, so the metal from the riser can be flowed into the mold cavity. So for this purpose riser is given. Okay, this is a sprue. So option C is correct, sprue and riser. The primary purpose of sprue in a mold casting is to feed the molten metal, to feed the molten metal from the pouring basin to the gate. Okay, so option C is correct, feed molten metal from the pouring basin to the gate. Okay, it does not feed the casting at the rate of consistent with the solidification, acts as a reservoir, help feed the casting until all solidification takes place. So these A, B and D are wrong, and it is that is through which the molten metal is fed into the pouring basin to the gate. So option C is correct. Blind risers are defined as options are tapering of thinner section towards thicker section, massive metal inserts of increased heat capacity, does not break to the top of the cope. Okay, so blind risers are, it does not break to the top of the cope, it will not come up to the top, so it will break at somewhere else. So it is called as blind risers. Okay, so option C is correct, it does not break to the top of the cope. Okay, similar to the case, it will not come up to the top. Okay, it will end at the middle or at the quarter of the path. Okay, that is called as a blind risers. State the purpose of riser. Okay, options: deliver molten metal into the mold cavity. Okay, this is not correct. This is sprue. And option B is feed the molten metal to the casting in order to compensate for the shrinkage. Okay, so it compensates for the shrinkage. So during solidification the metal shrinks. So in order to compensate for the shrinkage, and that is molten metal is poured into the riser. So option B is correct. Then shrinkage allowance is added to the pattern dimensions to take care of, that is options liquid shrinkage, liquid and solid shrinkage and solid shrinkage. So option C is correct, solid shrinkage. Shrinkage allowance is added to pattern dimensions to take care of solid shrinkage. Shrinkage allowance is made by options adding to external dimension, internal dimensions, subtracting from external dimension, internal dimensions. Option C, subtracting from external dimensions and adding to internal dimensions. So during shrinkage process, the metal contracts in size. So that is it has to be subtracted from the external dimensions and added to the internal dimensions. Okay, so the pattern should be of smaller in size. Okay, so option C is correct. Then match the following. Core. The core is used for making hollow castings. Option for core D is correct. Core is used for making hollow castings. So cores are made up of sands. So it is made up of dry sand. So and it has been inserted in between the mold cavity, and after the casting process is over, it has to be it has to be dismantled. The core can be dismantled and it became a hollow casting. Then riser. So riser, solidification shrinkage as shrinkage during solidification. Okay, option A, 2A. Then pattern allowances. Okay, solid shrinkage as shrinkage after solidification. Okay, and then so 3C. Then chaplets. Chaplets are used to, and 4B, used to support the core. Okay, chaplets are small metal pieces. They can be used to support the core. Okay, this is a core. The cores are made up of sand. This is a mold cavity. So while pouring the molten metal, the core is present. When the molten metal is poured, it will not fill into that core area. So after the removal of casting, the core have been removed and it become a hollow part. So this is the purpose of core. This is a chaplet. Chaplets are small metal pieces. They have been used to support the cores. Then core prints. So core prints options: strengthen the core, form seat to support and hold the core in the place. Okay, the core have been placed in the mold by means of the core prints. So at the end of the cores are made up of core prints. Okay, so core prints are used to form seat to support and hold the core in the place. Then a problem: a grey cast iron blocks. Okay, it is a cast iron block 200 × 200 into 10 mm and shrinkage allowance is 1%. It is asked to find the ratio of volume of pattern to the tough casting. So the volume of casting is, as it is a rectangular block, 200 into 100 into 10. Okay, this is the volume of casting. So at the denominator 200 into 100 into 10. But in the numerator, that is the ratio of volume of pattern. So pattern volume will be, it is 1% have been added. Okay, 200 into 100 into 10 plus 0.01. Okay, as it is 1% added, 0.01 into 200 into 100 into 10. Okay, this is equal to, if you cancel this, it will be 1.01. Okay, if you cancel all the V, it will become 1.01. So option C is correct, 1.01. Okay, ratio of volume of pattern to that of casting. So volume of pattern is original volume plus 1% of original volume divided by original volume. This is equal to 1.01. Which of the following materials require large shrinkage allowance while making a pattern for the casting? Okay, so the plain carbon steel. Okay, plain carbon steel require largest shrinkage allowance. Okay, you can see this here. Steel, option 4. So A equal to 4. Steel has, so option A is 4. Cast iron 10.4 and aluminium 17 and brass 15.3 and steel 20.8. So plain carbon steel, which are the following material require largest shrinkage allowance? That is plain carbon steel. Plain carbon steel requires largest shrinkage allowance. Okay, 20.8. Next comes aluminium. Aluminium requires also next largest shrinkage allowance, 17. Okay, so option A is correct for this case. The taper provided on the pattern for its easy removal is called options: taper allowance, draft allowance, pattern allowance, shrinkage allowance. The taper provided on the pattern for its easy removal is called as draft allowance. Okay, it is called as draft allowance. So draft or taper allowance. So if the sides of the pattern are made like that, as in the first diagram, the walls can be damaged. For this purpose, the pattern is given some taper. Okay, so and the very small taper, and this allowance is called as taper allowance or draft allowance. So taper provided on the pattern for its easy removal is called as draft allowance. Option B is correct. Negative allowance is provided on the pattern to take care of options: the distortion allowance, the shake allowance. Negative allowance is provided. Positive allowance is added and negative allowance is provided in the pattern to take care of shake allowance. Due to the shaking, the wall's size can be changed. For this, so negative allowance can be given. So option B is correct, negative allowance for shaking. Then directional solidifications in castings can be improved by options: chills and chaplets and padding, chills and padding. Okay, so during solidification, chills and paddings are used to obtain the directional solidification. So option C is correct. Which of the following methods are used for obtaining directional solidification for riser design? Okay, options: suitable placement of chills, suitable placement of chaplets, and employing paddings. So chaplets are used to support the cores. So option 2 is wrong. 1 and 3 are correct.